Hello, my name is Lucas Haddock and today I'm here at the Hexagon stand with Frank and we are going to be talking about the BLK to fly, the BLK to go and the BLK to, well, what's this one, Frank?
BLK 360, second generation.
So Frank, would you like to tell me about how these would help adapt to your work site and maybe make it more efficient?
Right, so anytime you need to measure anything, you've got existing conditions, you're designing a new building, well, you need to measure it to make sure it's fitting in the right place. This guy is a tripod mounted scanner. It's about a 1 minute revolution. You get imagery and very precise 3D coordinates. This guy is a mobile scanner where you're picking it up and you're walking around your job sites. So very, very efficient. This is the big brother to these two. This is a drone. It's a scanning drone. And you can see in the background there, that's the what the drone is looking at, the mission planning. So very efficient for scanning rooftops and areas where these two cannot get to. Would you like to see some data?
Yes.
Come on, check this out. So this is almost like my gaming 3D software. You play games, right?
Yeah,
I'm sure.
yeah.
What's your favorite? What's your...
Oh, a bit of Call of Duty.
Okay, well, they're using this technology to get the background of Call of Duty, of Fortnite. They're using 3D meshes. So I'm going to show right now. Here we go, right here. This is the backdrop of all of those video games, whether it's 3D golf or flight simulator with the airports, right? It's a mesh. It's a 3D mesh. It's not texturized yet, right? So what these guys do is they scan, they create a point cloud in a mesh, and then because it has photogrammetry cameras strategically placed, it actually creates a 3D mesh. So beautiful 3D mesh, right? So this is the backdrop of all of those games, and I'm using that because this is, you know, everybody knows the gaming industry, but it's also used in construction, in engineering, so you can measure buildings, you can measure piping, you can measure entire facilities and cities. Let me show that. Go back to site view here. All right. So this was an existing plant.
Existing mill, weren't you saying earlier?
Yes, it's a mill. It's a mill plant, and they're converting it into shops and restaurants, right? So you're looking at the existing conditions, what's called a point cloud, and imagery. So if I turn off the point cloud, right, this is all the beautiful imagery. So this is what architects are also using to design over existing conditions.
Frank, that sounds really good. You were saying earlier about how precise this has become. You can measure millimeters even.
Correct.
On these machines. This sounds brilliant. You were also saying about how you can have a look at all sorts of different areas of the site just from your machine, just from sitting down. You don't even have to do anything. You're going to have to measure it all, but this all just does it for you.
That's correct. So you walk around the site or you put a tripod on. We have different sensors, different scanners that have different accuracies. These guys are in the 1 to 2 centimeter range, while the walking ones are. The tripod mounted ones are in the millimeter range. The difference is these take longer than to walk around. But yes, we can get millimeter precision with these type of scanners. And what this does is it brings the plant or the facility to your desktop. So you can take any measurement you want, say from that wall, you know, down to this ramp right here. Very, very precise, millions of points, millions of measurements.
So you're also telling me, Frank, about how these have adapted and they have evolved as such from being these big,
behemoths,
bulky pieces of machinery.
Yes.
And now they're just handheld and you can just go from it being 5 hours or 6 hours to go around the whole site to it maybe being 15 minutes to half an hour.
Yes. Lucas, when I started this laser scanning with Leica Geosystems 20 years ago, the scanners were huge. It would take a couple of crates just to wheel them around. The batteries were the size of 2 car batteries. We went from that to this. The battery of this guy, it's insane. This thing right here lasts 45 minutes. It barely weighs anything. So we've come a long way since I started laser scanning in the industry. Right now, look at this, Lucas. It's off right now.
Yep.
You press, it's a one button operation. Press one button, 15 seconds later, it's calibrating and it's gonna turn on and you're ready to start scanning.
And it's just scanning all around us already.
When it turns green, it's gonna start scanning all around us. So we can walk around. It doesn't matter if there's people in the way. We could delete those later in the office.
That sounds brilliant, Frank. I would also like to mention how you were saying that it will just make everything faster. It just makes everything so much quicker from what you were saying to me earlier.
Yeah.
How it just shows people what the precise measurements are and everything.
Yeah.
How do you think that will adapt in the actual workplace?
So you're saving so much time, right? Whenever you're not in a certain area like a plant, it's very dangerous to be in a plant. The owners of a plant, a process plant, a nuclear plant, a paper plant, they don't want you there. But you're like something that's needed. You have to be there in order to measurement so that they could say, add more piping so they can add more rooms to it. Well, the less time you're there, the happier they are, the safer it is, because there's not a chance that you're gonna trip over something, you're not gonna fall on the ladder. Back in the old days, it would take months to scan, to do something like this water treatment plant right here. So imagine trying to measure all of these pipes with a tape measure or with a total station, right? So now it's a matter of a couple of minutes and you're in and you're out, very safe technology.
How long did it take you to scan this, Frank?
You can see right here, this plant took me 409 seconds.
That sounds brilliant, Frank. I would also like to add, you were showing me earlier that there was a little bit about maybe the new parts of constructing a building.
Oh,
so
yeah.
say there was an older building and you were adding new bits. Would you like to show us about how that works?
So this is great. You have an existing building that's under construction. So you've got a structure, a building. You could see this is just the frame. It's the steel structure there. And you need to measure for two things: for progress, how far you are in the building's life cycle, and number one, to see how it's fitting into the design that the architect and engineer designed, right? So we can do a virtual walkthrough just by clicking on all of these panoramic images, right? So now this is bringing the building from the field into the office. I can fly through here, and this is available to anybody. This is a free viewer called TrueView, like a TrueView, right? So you can measure, you can check that against the tolerances, against the design to see if that is the correct distance. But what's even better, Lucas, is you could bring the design into this existing conditions and check to see the tolerances. I'm just gonna drag and drop. That's how simple this stuff is nowadays. And now you can see the design just pop right in where it goes. So if something's off or not built, let me check it in here. So you can see, I'm flying through here.
So you can see the existing structure and the structure that's meant to be placed in front.
That's right. So now when this one's ready to be placed, we would scan it and then we would throw that other structure in there. We can clearly see that this part has not been constructed yet. So you know the progress of that building.
All right, that sounds brilliant, Frank.
Yeah,
thanks for running us through that. And I would like to see you again soon, maybe out in the field.
Thank you, Lucas.
Thank you for your time.
Appreciate you, sir.